Hello, everybody. My name is Alexander Stammler. I work at Growatt for 3 years and a couple of months. I started as a service engineer, and now I'm product manager at Growatt. And today I will conduct this webinar in English. Here I have the agenda. So I will start to introduce with just a couple of slides our systems that we have. The XH systems and the HU systems. Then we will go over with one slide only to monitoring and data logger. And then I will go into more detail about the systems, the MOD and the MID XH, plus the APX battery and the SIN, the backup box. So there will be more details also on installation. Furthermore, we go, the next step will be the mod and the mid HU systems with APX. Then I go into the Grow Boost, the Thor EV charger. Eventually, I will present our solutions to paragraph 14A EnWG in Germany. And I will finalize with the WIT 29.9 to 50K. I have one more topic, the QuickSight setup, which I would like to introduce, but we'll have to see what the time says. And that would be the agenda for today. So starting with the XH and HU system. So the battery ready systems for us, the XH and the HU systems, just the overview. We have here from 3 to the MOD from 3 to 10 kilowatt AC output. And the MID is from 11 to 30 kilowatt AC output. We have the MOD HU, which goes from 3 to 15 kilowatt output, and from the MID from almost 30 to 50. Then we have two different battery systems that I present here, which are the newer ones. The APX system, which we can do with the MOD, we can do up to 30 kilowatt hours of capacity. The MID can go up to 60 kilowatt hours of capacity. Then there is a second generation coming out. This one is very similar. The capacity for the MOD is 30 kilowatt hours, and for the MID HU is gonna be up to 90 kilowatt hours. Commercial and industrial inverters, we have the WIT 50 to 100K HU, which is certified VDE VDE 4105. So also the WIT 30 to 50K is also certified for 105, and only the max is certified for 110. We can connect the WIT systems with designated battery systems like the AXE or the ACE for the WIT 50 to 100, and the WIT 29.9 to 50 we can connect to the AXE indoor and outdoor system. So that's just a short introduction. Now the monitoring, we have many different devices for monitoring. The data loggers, which are needed to connect to the internet and thus bring the data of the inverter to our cloud. I recommend everybody to only use Shine VLAN X2 from now on. My experience is, and also the feedback that I get from field is this device, this data logger is much better than the previous Shine Wi-Fi X or the Shine LAN X. Yeah, this one includes Wi-Fi ability and LAN ability. Exactly. I will not go more into detail of all of these. There are some for parallel communication and so on. Otherwise, it would be just too big for this webinar. Then for monitoring, the customer can use the Shine server to see all his data. He can also use the Shine phone app. And for installers, they have the the Shine Tools app, which I recommend to everybody when it comes to installation. This one can connect with the data logger via Bluetooth. So no internet is needed. For example, if you're in a cellar and there's no internet, you can still make configuration with this app. And later on, you can also do updates through this app. And later on, when you're at home and you have an issue on one of the systems, or you have the OSS to see all the systems that you installed, here you also can do updates on the inverters. So coming to the MOD, MID, XH, exactly, system and the installation. Here it's just again the overview. We have the mod XH and the mid XH systems, which are both compatible with either APX generation 1 or generation 2. To see the difference between the two inverters, they're quite similar, only by size a little different. We have different AC output connection. The communication plug is the same, although the communication pins are a little different, which I will show later. Then we have the USB for connecting the data logger, and here are on the MID we have 2 battery ports, so we can connect 2 clusters. And here we have 1 cluster, which is plus, minus, and neutral. And then we have the designated here MPPTs. So the MID has far more. Here I have an overview. Number of MPPTs for the MOD is 2. And for the MID is depending on size, 2 or 3 MPPTs. Strings is 1. Here we have 2. Maximum input current is 16 ampere. Here we have the double because we have 2 strings. So for each string, it would still be 16 amperes. Then the voltage range, so also starting voltage is 140 and here 160. I recommend not to go over this 1000 volts when you plan the system. Also, always make a little bit, go a little bit underneath the voltage because there's still some discrepancy, and I would not go up to the limit. Then you have a DC-AC ratio of 2, which is pretty good, meaning you can install, let's say you have an inverter, an MOD 10K inverter, which is able to export or to produce 10 kilowatt of AC power. This inverter, you can connect up to 20 kilowatt peak of PV. When the panels produce 20 kilowatt peak, then 10 kilowatt would go into the battery and 10 kilowatt would go into your household or export. Yeah. Once the battery is full, the inverter is still only able to produce 10 kilowatt hours, 10 kilowatt of AC power. Yeah. So even if you have more installed in the PV panels, the output of the inverter will not increase. To our batteries, the APX battery is exactly here. We see we can we can upgrade the battery pack anytime. So you can install it at first stage with only 5 kilowatt hours. So one battery pack here has 5 kilowatt hours and it weighs about 50 kilos. This is the power module, the BMS, which is connected to the inverter. So you need at least 1 battery pack with the BMS to be working. And you can anytime upgrade the system and buy another pack and increase the capacity of the system. Yeah. The battery also has a heating for low temperature. So in case you install it in the cellar where in winter time it is like 0 degrees, it uses part of the PV energy to heat up, because otherwise lithium batteries are not able to charge very good. Yeah, so this problem is circumvented by heating, similar as in a car. and then it also has a sleep and an eco mode when the battery, for example, is empty, and it cannot, and it sees, the system sees there's no PV coming in, so there's no chance that I can be charged. Then it goes into sleeping mode, meaning it will reduce the self-consumption energy. Yeah, because of course, if the battery is on, it will use up some power. The second generation is not so different. The big difference is, one, the battery packs are 10% lighter, so they're 45 kilos. They have some handles to carry. The BMS also is included with 5 kilowatt hours of battery storage of capacity, so you can use this module alone with the inverter. You don't need to buy one BMS plus one battery. The communication goes all with one integrated cable, and it's stackable without cabling. So you don't need cables between the different battery packs. The old, or the first generation, you always have here to connect with cables between BMS and each of the battery packs. Here we see the difference in the communication adapter for MOD and MID. Yeah, so the same is here when it comes to the smart meter connection and the first battery pack. They're the same. And then the SYN box, so for backup, you have a different connection on the MOD XH. Here we have 1718 and 2122. And the MID XH has 21 to 24. So here are the pins. You see here, this one is 11. Here we have 20. So 21 to 24 would be those here for the MID. And then we have the ability to connect the second battery pack or cluster on the pins 27 to 30. In general, the inverters should come with this adapter. So it's not necessary to know all these pins, which battery goes, or the battery goes to which pins, or the smart meter, but still not all of the inverters have this adapter. Some older ones don't have this adapter, and also if there is ever an issue, it's always good to have somewhere the documentation where you can look up which pin is connected to where, so you can eventually connect directly the pins. So here we have this connector, which is one connected with the SYN box, the backup box. For MID, we have two battery cluster connectors, and we have the meter. On the APX, first generation, we have two sides. The right side is connected with the inverter and with the battery packs. And the left side here is only for MID if you do two clusters. So if you want to go up to 60 kilowatt hours, it means you need two clusters, you need two BMS. I have later another slide where I show this one. Important is, if you connect the batteries and you make two towers, for example, if we have more than 4 battery packs, we recommend to make 2 towers. Then you need this extension cable, and please connect the extension cable in this way. So 1, 2, 3, 4. I had one customer who connected it 3 to 6 because he said then it's a little bit longer. He needed more space, but that doesn't work. Yeah. Here, just for your documentation, you have again the different connectors, and it's important, which connector goes to which pin. Smart meter, we often have issues with that on the field because on the one hand, it's been wrongly connected, especially before this adapter was in place. We often had here that pin 24 on the chint, for example, was connected to pin 16 on the COM plug of the inverter. So here it's also, you can see it if you ever have an issue. Exactly. So there's different pins for the Chint and the Eastron. Those are the two smart meters we usually use. I said we have the Chint and the Eastron, but we have two different versions of the Eastron right now in the field. One where the load is connected from top, and one where the load is connected from bottom. So this one is the newer one. If you buy a new system or if you buy a new Chint, you might get this one where it's written on. The old one, it's not written where it's supposed to connect the grid or the load. So you have to look here on the side is usually this this little sticker where it's written 1, 4, and 7, for example, goes to the grid. Yeah, please just keep this in mind. We also had often issues with wrongly connected either Eastron or Chint. Startup procedure for the system. If it's all off, so start with the DC switch of the battery and turn on the battery. Wait a couple of seconds, then turn on the DC switch of the inverter. Wait another 1 minute, and then plug in the grid power plug in the grid power for the inverter. And this way, it's the best way to start the system. If you do it in a different way, which I did also quite often, most of the times won't happen anything, like nothing bad, I mean, but still it's our recommendation. And the other ways, there are options that some fuse might blow up if you if you don't do this process, which didn't happen to me so far. So yeah, if you do it once or twice or a couple of times wrong, it's not going to be the end of the system. Required settings. So once you installed the system, you only have 2 required settings. And even this setting is not 100% like necessary for the system to work. But I recommend to do the country setting. If it's Germany, put in Germany. If it's other countries, or I talk about Germany, yeah. If you don't do Germany, then it will have per default Austria, Netherlands, which is okay, yeah. But if you're in a different country, always do the country. The more important even is the smart meter or export limit. If you have a system with a smart meter connected, and as soon as you have a battery, you need a smart meter. You always have to manually configure either smart meter or export limit. Otherwise, the system will not look for the smart meter, will not get the data, and then the system will not work properly. It will not give you necessarily a problem report, but it will not work as supposed to. For making settings, you have different options. You can use the ShinePhone app, but not your installer ShinePhone app. You need to use the account of the end customer. That's a little bit an issue. You can use the Shine Tools app, which I prefer, which works very good, as I said. Or you can also do the OSS system or the web browser. Yeah, of course, for all of this, you need the data logger. Yeah. If not, most of the settings you also can do with the touch screen. But the feedback that I got is that the touch screen is hard to handle. So yeah, better with the data logger. Here I show if you do the with the ShinePhone app, you go to control, and then here you have the smart meter settings, which are either one. Yeah, so you can either do export limit or you have to do power sensor. But usually now everybody does at installation 60% export limit. Then the system will ask you for a password. The password is always depending on the date, so it will change every day. And for the 31 of December 25, it was Growatt 2025-1231. So the date just in reverse. And yeah, always the date of today. If you use the Shine Tools app and you connect to the system, you go to quick settings, and there you can do the country regulation, the country setting, or as I said, the power sensor or export limit settings. Yeah. So here is for the XH systems, MOD or MID XH. We need an extra backup box to be able to use the backup function, or yeah, in case of that the grid goes off, the system would the inverter would usually turn off, which is necessary, or which is a demand. But if you use the SYN box, the inverter will stay on. This SYN box is compatible with both MOD and MID XH, not with the HU system, which I will introduce later. So this one can go up to 40 kilowatts, and it has like, where's the ampere? Yeah, 63 amperes divided on the three different phases. It has a switch of less than a second, so 500 milliseconds. So it's not, yeah. If you have like a server or so, it will not be quick enough. You would need an extra device for a server. Yeah. Maximum continuous input, exactly 90 ampere. Maximum AC input overcurrent protection, 128. So this box is installed between the inverter and the smart meter. Smart meter is connected to your inverter, and inverter is connected with AC power and with communication with the SYN box. We recommend, although the SYN box can handle, like as I said, 40 kilowatts, we still recommend not to connect everything on the SYN box, because when the grid goes off, the SYN box is limited to what the inverter and the battery is able to produce. And if you have a 10 kilowatt inverter, it will only give you 3 kilowatt per phase. Yeah, meaning if your load is very big, you have an EV charger, so that you happen to turn on when the grid is off, your inverter will go in overcurrent and it will just shut down. Yeah. So either keep that in mind. I mean, you can connect everything here, but then keep in mind for the end customer to be to take care once the grid goes off, or you connect big loads which are not so important outside. Yeah. Here we see the connection. As I said before, it's different on the MOD XH and the MID XH. We have here these two pins, which is 21, 22, and here the 17 and 18. So I have it here. Exactly. It's good for your documentation if you ever encounter the case that you have some issues with the connection, or you don't have this adapter. It's good to know where to plug in what. Inside of the SYN box, you have these switches. And if you do all the switches up, or let's start like this. Normal case is this switch, this breaker is down, and the other breakers are up. This one is inverter, and this one is for load. This one is a bypass. Yeah. So in case, for example, the SYN box has an issue, you push up the bypass switch, and then the power just bypasses from the grid to your load. If all of them are up, then the inverter goes into standby. Yeah. So also, when you do the installation and you have your Wi-Fi on the output of the SYN-box, you either have to put in manually the setting of backup box, because if you don't, so you install both and there's no electricity, so you didn't do any setups. Yeah, this means the inverter doesn't know that you have a backup box, so they don't communicate. That means this one will not provide energy. Yeah, so there's this issue. You have to put the setting in the inverter of enabling backup. And then this one will start providing power. Unless you turn on the bypass, then the power will just go through, and then you can do the setting on the inverter. The setting via OSS here, so you can do the setting also on the Shine Tools app or the Shine Phone app. But you have the different settings here. Off-grid function it's called. Then the first two you have to enable. Yeah, and the third one is optional. The third one is, for example, that if the battery system goes into sleep mode, you can say that one battery pack stays awake. And this way, when a grid outtake comes, the battery doesn't have to start up first to provide power in the night. Yeah. Otherwise, it's the first has to wake up. It has to start. It takes a couple of seconds and so. Yeah. So it will take longer. The other option is one battery pack always is on. This means he will use up some energy, but the system will react according to the 500 milliseconds. Then you can put in different SOC levels, which is important for the backup system. So you can here put, for example, on-grid battery discharge stop SOC. This means in normal situation where you still have grid power, your battery will always discharge from 100% up to 20%. Yeah, for example. You can put in here also 15. The minimum is 10%. So what happens if you put in here 10% as well? Yeah, this one is off-grid battery discharge stop SOC. If both are at 10% and the battery is down at 10% and suddenly you have a blackout, you have no battery left to provide for your household. Yeah, so if you have here a slightly higher number, then you keep like a little buffer for worst case scenario. But that's up to you. You can do this as you wish. Yeah, some customers have 15, some customers have 10, others have 20. You can also change that for winter time, because in winter time, if you have a big storage, usually the storage doesn't charge to 100% anyways. In that time, you can increase it, for example, here 10 and here 30%. Yeah. So now I go, exactly, that's it with the SYN-box. Maybe, sorry for switching, but in my last roadshow, I got from many installers, they like very much this SYN-box. Also because they say sometimes you have the inverter in outside in the car parking or so in a garage, and the SYN-box is in the cellar. Yeah, in this case, you only have to put one cable from inverter to SYN-box. Yeah, if it's like 30 meters or so, it would be only one cable. If the inverter has the backup output, yeah, as the HU system or as other systems, that means you need two cables, yeah, from your cellar or where your grid access point is to the inverter. Yeah, which they say is problematic sometimes. Okay, so two APX clusters with the MID. I have this slide, which is a little bit confusing, but if you go step by step, it's very simple to understand. So that's the first battery cluster, 1 BMS. Here you go to the pin 7 to 10. And important, yeah, on the left side, as I said, you connect from linked out to the BMS2 on linked in. Yeah, if this is wrong, is switched, then you have a problem. Yeah, and exactly. Also, power you connect between those two. Yeah. Here we see it on the MID again. We have two clusters. So cluster A is this one, and cluster B is this one. Yeah. So meaning cluster A goes pin 7 and 10, and we use the link out to cluster 2. Another nice option that we have is the smart meter with six CTs. So if you have, for example, an inverter from a different producer or from Growatt, which is an old system without battery storage, you can use this 6CT smart meter to charge your own battery from the new system, and to have a correct monitoring. Yeah. If you just use a normal battery, a normal smart meter, the monitoring will be totally wrong. Yeah, your household will not be correct, because this inverter will produce energy which will flow into the household, and our system will not know this. So on your monitoring, the load will always be low or almost zero if this one is a big inverter. Yeah. Exactly. So you have here the option with the 2 smart meters, and he will use the overpower of this one to charge his own battery. You can do the same if you have the SIN box, the backup box. And here, if you use this one, you need to go to settings, either on OSS or on the display or on the on ShinePhone app. You have the setting working mode retrofit. Yeah, here is only on the different devices how you do the setting. And if you go for retrofit, yeah, you have to reactivate the backup settings on for your SIN box. Going over to the HU system. So the MOD 3 to 15K HU, 3 kilowatt up to 15 kilowatt AC output. And the MID is 29.9 up to 50 kilowatt AC output. They're also both compatible with the APX 1, Generation 1 and Generation 2 batteries. As I said, the MID will be, I think this one is still is coming, but it's not yet on the market. It will be able to connect up to 3 clusters, which would mean up to 90 kilowatt hours of capacity. If we compare the XH and the HU systems, we see the HU systems has more MPPT trackers. So we have starting from 10 kilowatt to 15 kilowatt, we have 3 trackers. And the MID, okay, the MID XH is only from 11 to 30 kilowatt AC output, and the HU is from 30, so it's much bigger, but it also has more MPPT tracker here, 3 and 4. Then the MODs have one string. This didn't change. Here we have 2 strings per tracker, but the input current, the maximum input current of the MPPT changed. So before we had 16 amperes, and now with the HU system we have 20 amperes, or here 2 times 20 amperes, since we have two strings per tracker. Then the starting voltage did not change, and the DC-AC ratio did also not change. It stayed the same. Another difference is, if we look here, so we have the load port. We have grid port, and load port is for the backup. Yeah. So you can connect your important load directly to the load port, and this way it will be fed with energy from PV and battery once the once the grid goes off. You don't need extra this SYN box as shown before. Then communication is directly via RJ45 connectors. We have a DRMS for paragraph 14A, which I will show later. We have parallel communication to ports. We have battery and meter. Also, there's one pin connector for dry contact. Yeah, we use the Shine VLAN X2 for this system only. Yeah, not the old ones. Then let me see. Yeah, I think the rest did not change. So here again, we see how we can use the backup. We have, of course, the connection to the smart meter, which is necessary once we have the battery. Then we can go the whole house, or we reduce to important loads and to other loads, which is my recommendation, especially because this one is limited to the same AC output on the load as on the grid. Yeah, so if you have 10 kilowatt hours HU system, this means 10 kilowatt divided by 3 phases. That means 3.3 kilowatt per phase. He's able to put out maximum. Yeah, even if the grid is there. So even if the energy comes from the grid, it's still limited to these numbers, 3.3 per phase. If you have a 15K inverter, it's 5K per phase. This is very important because I had also a different customer who used here EV charger and heating pump and I don't know, and the inverter always went off because overcurrent, overpower. Yeah. Then the next problem is, as in the old one, once the grid is gone, it's a blackout. The inverter is kind of limited to the power of the battery. Yeah. If you only have, for example, 5 kilowatt hours of capacity, the battery will be only able to provide you with 2.5 kilowatt of power. No? So yeah, keep that in mind when you plan or when you advise your customers how to plan the whole backup thing. Furthermore, this one is able to be connected in parallel compared to the XH. Mod XH does not work in parallel. The mid XH works in parallel, but the Mod HU works also in parallel. Up to 5 systems we can connect with the Shine SEM XAR or with the Shine Master. Yeah. If you do a parallel setting installation, it is a little complicated what you have to do in the settings and everything. So yeah, I recommend it only if you have a little bit of experience with the Growatt systems. Don't do it as your first ever installation. So that's it with the inverters. Now I go over to the EV charger. We have the Thor 11 and 22 EV charger, meaning one is either 11 kilowatt output or 22 kilowatt output. It uses 400 volt AC, so it's a 3-phase system, of course. And the 11K is 16 ampere and the other one is 32 ampere. It is, depending on which one you have, it is compliant with paragraph 14A, which I will later on show. But you need a certain sticker on the EV charger. Yeah. So many which are on the field and are distributed do not have the sticker, but I will show you later. Then it is able to surplus charging via CTs or smart meter. You can connect CTs directly to this EV charger or a smart meter. You can use it by using the app or RFID card or plug and play system. Exactly, it has also different charging modi you can choose of. It uses the Type 2 charger, the Mennekes charger here, which is compatible with almost all cars, I think, in Germany. Can charge with one phase. So it can charge with one phase or with 3 phases, but you cannot put the setting in the inverter. You cannot say, now I want to charge my 3-phase car with only one phase. That's exactly. So if it's a 1-phase car, you can charge it, it will only use one phase. But if it's a 3-phase car and it demands 3 phases, you cannot set, oh, I will only charge with one phase. If you on the side, I think on the other side, there's some screws and a cover which you can take off, and then you have these circuit boards. And here you connect the CT clamps if you want. And power input is here. You see here. You will not connect the power input, of course, from this side. It will go from underneath. There's a designated port for it, but then you have to exactly connect them here and screw them. Yeah. The app configuration is here with the Shine Phone app. You use so you have, at first you need like your own plant. Let's use the plant of your inverter. And then you can go on plus, add device, and you choose the EV charger and connect it to your plant. And then you confirm the serial number of the inverter, or not of the inverter, of the EV charger by scanning or typing it down. The system, so step 1, exactly. Of course, you need to set the Wi-Fi on your phone, and then you look for the Wi-Fi of the EV charger, which is the serial number. The SSID will be the serial number of your EV charger. Then you connect to this SSID of the EV charger, and you have to input a password, which is either 1 to 8, or it is the first 15 digit of serial number. Yeah? So it could be both. So just keep in mind, try the 1 to 8. If this doesn't work, then it's going to be the first 15 digit of the serial number. Then connect the EV charger to the Wi-Fi, go back to the Shine Phone app, and choose the Wi-Fi you want to connect to and enter the password that I wrote down here. Then click next and wait for 2 to 5 minutes for the connection to happen with the EV charger, and then you can go into the settings. One or the most important settings, if you use an extra smart meter for the EV charger, and you need a smart meter if you want to do surplus charging, then you need to put in the exact smart meter that you're using or the CT clamps that you're using. So you go to meter type, and here you can choose E-Stron SDM 630, so typically we use E-Stron or the Chint DTSU 666 or the E-Stron SDM 630. But exactly, just check out what smart meter you used, or if you use the CT clamps, then put this in. Yeah. Then you can go into the modi. You have 3 different modi. One is fast mode, one is PV linkage mode, and one is off-peak mode. So fast mode always charges your car with its maximum charging power. PV linkage mode is surplus charging. And off-peak mode, you can set up certain times where, for example, the energy price is very low, and then it charges at these times. Another limitation is the charging is with at least 1.4 kilowatt. If you have a one-phase car, yeah, you can charge with 1.4 kilowatt surplus, yeah, for at this one phase. But if it's a three-phased car, you need at least 4.2 kilowatt of surplus to start the PV linkage. So if you use the PV linkage mode, which is surplus charging, yeah, you need for a one-phase car at least 1.4 kilowatts of surplus energy, and for a three-phase car you need 4.2, which is a lot. Yeah, especially you have to think at first the energy will go into your battery, then it will go into your load, and only if you have more energy than that, then the EV charger will count and see, oh, now we have 1.4 kilowatt export energy. Now I will start my charging. Yeah. And then if it's a three-phase car, you need 4.2 kilowatts, which exactly is you need a big system to be able to have that kind of surplus, especially when it's not summertime. So exactly, keep that in mind. Okay, I will go on with the GrowBoost X. Here we have the system overview. The GrowBoost X. So there's a previous version, which is the GrowBoost without the X. The new version is the GrowBoost X. They both work very similarly, only this one is connected to the Shine VLAN X2, which is much better connection and far less issues. So here we have the overview. We have the GrowBoost, which is connected to a heating element, for example, on an electric boiler, and it can use surplus energy to heat up this boiler. Yeah, exactly. It communicates. It has no extra smart meter, so it receives its information from our cloud. It uses the Shine VLAN X2 to communicate with the router, retrieve all the information from the cloud, and then act accordingly. You can also set up the settings via the Shine phone on the GrowBoost X. Yeah, it's capable with three-phase immersion heater up to 10.8 kilowatt. You can also use a one-phase a load of up to 3.6 kilowatt. So there's exactly that's the GrowBoost X. If you open it, here are all the connectors. Here you only route through the cables, and then here you see the connectors. In this example, I have a one-phase heating element, which is connected here to L1. So we have here L1, N, and PE. Here we have L2 and L3. Yeah, so you can connect three individual one-phase loads or heaters in this case on each of those connector. Yeah? Or you can connect one three-phase load. Here's the example. If you use a three-phase load, you connect the different phases, L1, L2, L3, and then you use here N and PE, yeah, to connect it all with this three-phase heater. You also need It's not necessarily, but it's recommended to use a temperature controller or temperature sensor, which is the PT1000. Yeah. Otherwise, many of the options that the GrowBoost provides you are not able to be used if you don't have this sensor. Yeah. Here I also write down, so you have the option to use one single phase load, two single phase resistive loads, three single phase loads, or one three phase load and one single phase load is also possible. Here, if you have a three-phase load, only L1 is dynamically controlled. Yeah? Meaning L2 and L3 will provide the same energy throughout, and only L1, if you use how do you say, surplus energy, only L1 will be dynamically going up and down according to the energy that is actually provided by your PV. Yeah. Here I also write down maximum per phase is 3.6 kilowatt, which this device is able to provide. Then if you go into settings, you do add data logger, then you scan the QR code of the data logger of the Shine VLAN X2. And then you have here, you see the system, you can connect to it. I mean, you scan it, and then you have to put in the SSID of your house internet and the password so that the data logger itself connects to your Wi-Fi on your house. And then once this is done, you can go into the ShinePhone app and you can choose your GrowBoost X by clicking on it, and then you see the information, for example, total power right now. Here in this case, well, it was offline, but then it would show here, for example, 1 kilowatt or so, yeah, provided. And also depending on how many loads you actually connect, if you connected only one phase or the three phases. Yeah, you need to set up how many loads you connect to the GrowBoost X. If you go to information, you can here see the load is single phase. You can change it to three phase, and then give it a name. Yeah, for example, it's my immersion heater in the cellar, immersion cellar or so. And here you can put in the power. The maximum value is 3,600, meaning here you put in the power at what time, at what power he should start heating. Yeah, for example, if you have an output of 1 kilowatt, yeah, into the grid, then it should start heating. It's not recommended to use like 50 watt because it fluctuates a lot. Yeah, so if it's 50 watt and then if it goes under the 50 watt, then it stops again to provide heating power, and then you will have a turn on, turn off, turn on, turn off. So it's recommended to have a couple of 100 watts, or some even put in 1,000 or 1,500 watts when it starts, and then it stops heating when the power is below or when no power is exported anymore. Yeah. So here you go for mode setting, and you have the two different modes. One is smart mode, the other is photovoltaic linkage mode. The smart mode uses constant temperature mode. It sets a constant temperature, and the device will always maintain the set temperature, yeah, by using its own energy from battery, from PV, or from grid. Timing and control mode. You can set the temperature and time of repetition. You can use various time frames per day and saying, okay, in the morning from 8 to 10, I want to heat up my water, yeah, with this device, and then again at 1 p.m. to 3 p.m. and so on. Yeah, you can put the different timing, or you can put constant temperature so that the temperature does not go below a certain level. Then the linkage mode, which is the surplus power mode. Here you can put when it's exporting to the grid more than 1,000. That's what I said before. I think, sorry, here before, this one is only the power is like the maximum power of the heating element. Yeah. So if your heating element only supports up to 2,000 watts, yeah, then you have to put in here 2,000 watts. I explained that before wrong. Here's the correct way. So here, when you export to the grid more than 1,000 watts or more than 500 watts, the system will start to use the power for heating, yeah, up until there's no export anymore. Yeah. Then you can also set execution time for the linkage mode as well. And yeah, and then you can see here, for example, the linkage mode, the linkage name of this certain heating element, and you see the associated meter, which is necessary. Yeah. But this one he will recognize by itself if the system works fine. So your inverter is connected to a smart meter, and your Grow Boost X is linked correctly to this inverter, then he will retrieve the information from the smart meter and see, okay, how much export do we have right now? Will I start or will I stop? Yeah. Exactly. And then there's also this option of enabling heating protection, meaning yeah, that the temperature of the water should not go below a certain threshold. Now we come to paragraph 14a EnWG. So I use, as an example, I use the FNN Steuerbox and the gateway. So you need in Germany exactly if you have a load which is controllable and which is able to consume more than 4.2 kilowatts, then you need to be able to control this load. Yeah, that the grid provider can say, okay, now we have a bottleneck. We have not enough energy in the grid. We want all these big loads to reduce their consumption to a maximum of 4.2 kilowatt. Yeah, and they want to use it by exactly this Steuerbox or Rundsteuerempfänger. So we used all these switches. They have relays, yeah, which the grid provider can access and can control. Yeah. So if they say now we have the bottleneck, they switch in this example W4, the relay of W4, they switch, and then our system should exactly limit the consumption of the battery from the grid to 4.2 kilowatt. Yeah. This is exactly limited to EV chargers because they can consume more than 4.2, and it's our batteries which can also consume more than 4.2 kilowatts. Yeah. Some of my installers said, if I simply put the setting in the inverter, no grid charging allowed, then they don't necessarily have to use this connection. Yeah, I'm not sure. As far as I understand, it has to be something that the end user is not able to set. Yeah. So for example, if it's only a setting, the end user can unset the setting or disable the setting. and then the battery would be able to use more than, or use grid power to charge. Yeah. So from my understanding is you still have to do the cabling, and the installers that I know, usually they just route the cable because almost nobody so far has these devices from the grid provider when they install the PV system. Yeah. So with the HU and with the HU system, we have the DRMS contact. Also with other systems from us like the SPH, all of them who have a DRMS contact, we use this one for the export limitation controlled by the grid provider, and for the import limitation controlled by the grid provider. So the export is EEG paragraph 9 or so, which says to a certain time the grid provider needs to be able to shut down export up to 0%, 30%, or 60%. Yeah. So we also use for these functions the different switches, the different relays on the FNNs on this Steuerbox, or yeah, exactly. So if you have the DRMS contact, you use this one. You connect all the switches, all the to this one. If you have the XH system, the MID and the mod XH with the COM, you need to connect them here to the individual pins, which I will show here. Yeah. So on the mod and mid XH, you use pin 14 and 16 for the paragraph 14A. Yeah. This one shows only the paragraph 14A, so limitation of incoming current, incoming power to 4.2 kilowatt. Yeah. So if you connect these two to the switch, to the relay, in this example, relay 4 with pin 14 and 11, and this one the grid provider says now, then here we have a short circuit. And if we use here short circuit, then the battery will only be able to be charged with 4.2 kilowatt. Yeah. So charging limitation to 4.2 kilowatt is shorting pin 6 and pin 4. So that's the HU. Yeah, the HU uses the RJ45 connector, which has 8 pins. Yeah. Here we have 1 to 8. There are 2 different connectors. There's either the A or the B. So depending on these two, the colors are simply different. Yeah, but nevertheless, here we don't go for colors. We go for pins. So it's pin 4 with 6, meaning here 4 and 6. If I short circuit those two, then the battery will only be able to charge with 4.2 kilowatt. Yeah. If I short pin 3 and 5, so here 3 and 5, then the AC output power of the inverter will be limited to 60%. Yeah. So if you have a 10 kV inverter, which is able to provide 10 kilowatt of AC power, and we short circuit pin 3 and pin 5, then the AC power will be limited to 6 kilowatt. Yeah? It's not the export power that will be limited, it's the AC power of the inverter that will be limited for this period of time. Yeah? The same is here with pin 2 and 5. It's 30% of the AC power of the inverter. Yeah? Here we have the XH system, so the pins are slightly different because we have this connector, of course. Shorting, well, 15 is irrelevant because 100% is normal. So shorting 13 and 15 means 60% AC output. Yeah? 12 and 15 is 30% AC output. 11 and 15 is 0% output, so it will stop production totally. And 14 and 16 is the limitation of incoming current for the battery. Yeah, so that's for the inverter. And then when it comes to the EV charger, we need to do the same. If your EV charger has this sticker, supports RF communication and supports ripple control, which is the important part. Yeah. Then it has a designated DRMS contact, similar to the Mod XH systems, where you connect the relays. If not, then we have no other option, especially the ones that are already installed. They usually don't have this. Then we don't have the option of connecting the pins. Then what we have to do is the control box, once the relays switch, we need to go to a contactor which cuts the whole power, the whole AC power towards the EV charger. Yeah? This way is the only way to be conform with paragraph 14a of EnWG. Yeah? So it's going to be a hard break, and the system will not be able to retrieve any electricity at that time. However, it sounds bad, but from everybody I talk to who has some knowledge about it, they say the grid providers will almost never use this function, because if they use it a couple of times or so, then they're forced to do some reconstruction of the lines and everything. So at least that's what I heard. Yeah, this function will in most cases not be used. Yeah. Nevertheless, you as an installer, you have to make sure that there is an option to cut power or to limit the power. Okay, that's it with paragraph 14a. Now I go over to the WIT 29.9 to 50K XHU. It has 4 MPPTs, each supporting 2 strings. It has also a DC-AC ratio of 2, similar to the other systems that I showed. Maximum string current of 20 ampere, also the same. It has 150% overload capacity in off-grid mode, meaning, for example, here, the 29.9 kilowatt AC output inverter can backup power here, maximum output current, here, 1.5 times of the rated power for 10 seconds. Yeah, so if you have high consumption for starting certain motors or so, this one will be able to produce to deliver 150% overload capacity. Yeah, exactly. So this system is available in different sizes, 30 kilowatt, 29.9, 36, 40, and 50. Here we see the connectors. We have this generator terminal. This one can be used for various options, as it's shown here. So you can either connect a generator, you can connect a PV inverter, or you can connect a smart load. Yeah. Then you have the option to connect 2 smart meters, and it supports up to 3 different battery clusters. So let me go one moment. Yeah, here I will go a little bit more into detail what the generator port can do. So I said multifunctional generator port, it can connect a generator. It can connect the smart load and the inverter. So if you use a smart load is load management, meaning if you had a blackout, then you have, for example, some loads that you say they're nice to have, but they're not necessary. Yeah. So for example, you set in a value when the battery is at 60 or 50%, like here, then I want this certain load to be turned off. Yeah. So it's a load management. It says the battery is down to 50%. Now the heating pump or so is turned off, because otherwise I need the rest of the capacity for important loads. Here's the other option. If I use the generator, I can connect a generator which is not bigger, or the AC output power is not bigger than from the inverter, is important. Yeah. And you can set in a start SOC and a stop SOC. For example, when the battery in off-grid function, when the battery is at 20%, I want the generator to start and to charge my battery up to 50%. So this way, I'm certain that I will always have power. Yeah, even if the power is produced by a generator, which might be a little bit more expensive, more waste. But this way, I'm certain to not go below, or to not go below my energy necessary. Yeah, so that the system doesn't turn off. Yeah, I think it's clear. Okay, then the inverter can be connected in parallel, but in this case, one can connect one generator for all ports, or you can connect each port with one generator. If you connect an inverter, yeah, on the generator port, like here, then the advantage of this system is, if the inverter is connected normally here to the grid side, then if a grid outage is, then the inverter would turn off. Yeah. If it's connected here to the gen port, the WIT inverter will simulate a grid and provide the necessary frequency and voltage. And this inverter will still be able to run its energy and to keep on producing. Then you can use this extra energy to power your battery or to power your backup load, which is here the primary load is your backup load. So you have these three different options. Then I said you can connect it to a battery. Here we have the example of the outdoor AXE battery, which is available in 60 kilowatt hours capacity or in 50 kilowatt hours capacity. You only can buy it in whole storages, as far as I know. Yeah, meaning you cannot create like 75 or so. So you need 60 or 120 or 180 kilowatt hours, yeah, which you can connect. I said you have 3 connectors on the inverter, so you can connect up to 180 kilowatt hours per inverter. Yeah. It supports continuous charging and discharging at 1C, so in 1 hour, charging up or discharging. Supports parallel communication of multiple cabinets. It's air-cooled, IP55, pre-installed. Exactly, the batteries are pre-installed, and it's here connected with the WIT 29.9 to 50K. If you want to create bigger capacities and bigger systems, I said you can connect them in parallel up to 6 WIT with in total 18 AXE high voltage battery. So each of the WIT with 3 batteries makes 3 times 6 is the 18 batteries, which means you can have a pretty big system there. The other option is you can use 9 WIT systems plus 9 AXE high voltage batteries plus 3 grid-tied inverters. So there are some options you can use here for parallel communication. Also, the generator here can be connected to each of the generator port in total, and you can parallel connect the backup connectors of the inverter to the primary load. Yeah, so that the primary load is fed by the 3 different inverters. No, I think here's the same. Yeah, the backup ports can be connected in parallel or used individually. Exactly. So either parallel or each of the inverters has one generator individually. The generator connected to all gen ports, generator power has to be smaller than the inverter power. So if you have a 30 kilowatt hours inverter, the generator is not supposed to be able to produce more than 30 kilowatt. Yeah. In parallel, you only can use the generator port for generator. No smart load and no inverter can be connected. Yeah, here's also if you use parallel communication, you need either the SEM XR Air, which is the head, the digital head for communicating with all the systems, and there you have the different connectors. So 2 connectors go to the WIT inverters, and then the battery goes to 1. But that's very specific, just in case that anybody plans a big system. So we have enough time for me to present you the Shine tools, which, as I said, I think is a very good tool. And every time I showed it live, especially, people liked it. So you can log in. You have to download the Shine Tools app, and you have to log in with your installer account. You have to set here Germany and accept the AGBs in German. Then when you log in, you encounter this site. You can do quick site setups. So if you want to do, if you just installed the system, and you can do the quick site setup, which includes all the steps. Yeah. The other option is you just want to do some settings, for example, on a system that is already installed, or you just want to do an update. You can do it via commissioning. You connect here with the data logger and can do the commissioning and the update. Yeah. For example, you have the settings, quick settings, as I showed before, for smart meter setting and country here, export limit, exactly. There are lots of settings you can choose here from. And then under device information, you can do, you can do the update. Yeah. Once you open the device, the app, it a small package, which is just megabytes, I think single-digit megabyte size, and this one includes all the firmware for all the inverters, or for many inverters. Yeah. My recommendation: use even this function only with the Shine VLAN X2. If you use the quick site setup, you have to use the Shine VLAN X2 system data logger. So what it does is it does the whole installation with you. First, you create an account for the end customer. Then you create a plan for the end customer. Then you connect or you add the device, the inverter, to your plant or to your customer plant. You have the option of upgrading the whole system, either inverter or battery. Then you do the network configuration so that the inverter is connected to your household internet. You do quick settings, which shows only important settings like country and smart meter or export limit. Then it does the diagnostics, and then it gives you the option of doing pictures. This one is, from my side, also very important. I will go into detail later. Yeah, and at the end, it will provide you an installation information. So you start the setup, and it will tell you create new user. Yeah, it's just a couple of information you put in here. Then you have the user account. So use your username and user password that we will provide to the end customer. And then email. I think email is not anymore necessary as far as I know. It's maybe phone or so. Yeah. Then the next step, then you go confirm, and you go to next step, create new plan. So it will go from one point to the next point, always by next. Yeah. Then you create the plant, which is also just a couple of information. Most of them are already automatically set, like time zone. You just put a plant name and the capacity. and then you confirm and go on. And then it connects to your system, and it looks for what do I find? Yeah. So it looks for, is there an inverter, is there a smart meter, and is there a battery? For example, if the communication, if the cabling is not correct with a smart meter, it will not detect the smart meter here. And then you will already be knowing, oh, okay, there's an issue. So you do confirm, and then it gives you the option of doing updates. Here, for example, the APX battery has already the latest version, but the inverter could be upgraded. Yeah, you always have the option to skip. If you say I have no time, you just skip because it takes a couple of minutes. Yeah, or you do upgrade. My recommendation to do the update is my recommendation. Then update is done. It tells you also what is the update for. Here, for example, yeah, usually optimizing the SoC logic, blah, blah, blah. No? Here then you see, for example, inverter has 2 firmware updates. It shows here 2 of 2, so it's already finished with the second update, with the second firmware data. Yeah, and then it shows both are at the latest version. Here I say battery or inverter update optional, recommended, can take up to 30 minutes. Alternatively, skip. The next step. Oh yeah, okay, I jumped a little bit to not include all the steps in it, but they're self-explaining. For example, connect to the internet, quite self-explaining. And then it would be quick setup, which I also don't show, which is the settings that you put in. For example, country code and export limitation. And then it will go to installation diagnostics, which I like. You can do it or skip as well, but it will do like for 3 to 5 minutes. It will make a short analysis and then provide you with information. For example, this one I tested here in my laboratory, and it showed me PV port working abnormally. And then if you go into it to see, okay, what exactly, it will provide you the information. MPPT2 PV voltage is lower than 160 volts, or PV is not connected. And in my case, it was not connected. I just have one source, which I connected to the first MPPT, and the second one was without. So here it gives you also solution, check the PV connector and the voltage. Yeah, if you're below the 160 volt, or if it's not even connected. So it's nice to have. It's not necessary, but it's nice to have. Here, this one is from my side necessary. That's why I said do not skip here. Of course, you can skip, but don't. It just takes a couple of minutes, and it will help you a lot. Not necessarily, but possibly, maybe. Yeah. So you can upload the different photos of your inverter, of your smart meter, of your battery connection. If you ever encounter an issue with the system, like after a couple of weeks or so, something is not working, and you have to contact Growatt, yeah, support, then usually if there's might be an option that something with the connection is wrong, we will ask you for pictures. And if you don't have them, often they will say, okay, we need those pictures to be certain that it's not simply misconnected. That means either you have to go to the end customer, or you have to ask the end customer, please send me pictures of this and that. And then maybe the end customer doesn't know, he makes the wrong pictures. And this way is like the starting, or this way communication goes very slow, because you will send us an email, we will ask you, send us picture. Then the next day or a couple of days later, you send us a picture. We say, oh, those are not, we cannot see anything, blah, blah, blah. My point is, make those pictures. It takes you 2 to 3 minutes, yeah, maximum. And then eventually we have these pictures in our system, and we do not even have to ask you for pictures. We can see them, and we can directly say, okay, maybe it has something to do here with the connection, or it has nothing to do with that, and we can go for the next step in error finding. Here also, you as an installer, if you go to device list and you made the pictures, you will see here this option with this picture. If you go there, then the pictures are visibly to you as well. And also this, at the end, you get like this installation information where everything is written down. Yeah, is like the firmware, the current firmware at installation that is on the battery and on the inverter serial number. And yeah, if you do the diagnostics, it will also say here diagnostics, everything went fine, this and this and this tested. Yeah. So this is also something you can give to the end customer for his data to, yeah. So he has something to hold in his hand and say, okay, at installation, everything went fine. I have here this from Growatt, this protocol. Yeah, so it is a very good tool, and I really got a lot of positive feedback on that. At that point, I'm done with the webinar. I say thank you very much for listening, and I ask you, please, whoever can, here scan this code and provide some information about the webinar.